This is Go Figure, lesson 45 of Saxon Algebra Half, volume. Here's a warm-up problem. Find the area of this figure, and in case you couldn't tell, these are right angles here. So go ahead and find the area of this, press pause, and then check your answer on the other side. Okay, so to find the area of this, we need to divide this shape into two parts. So I'm going to make a dotted line here, make a right angle there. So we have two parts. We have this triangle and we have the rectangle here. The rectangle is 5 by 6. So that is 30 square units. We don't know what units they are, so we'll just call them square units. And then this triangle is, the height is 6, and the base would be, this whole thing is 8, but this part up here was 5, so this remaining piece here would be 3. So the base is 3. So we to find the area of a triangle, we do base times height. So 3 times 6 is 18, but then we have to divide it by 2. So that would be 9. So if we add our two parts together, you have 30 plus 9. So 39 units squared, we'll say. Is the area of that figure. All right, our learning objectives today. We're going to go over the vocabulary related to volume. We're going to find the formula for volume of a solid, and then go ahead and find the volume of right solids. So volume is space or a solid that has depth as well as length and width. So we know that area, right, is of a figure is length times width. That's what we're accustomed to, area. But volume is not flat, it's three-dimensional. So if we add another dimension to this, if we add some depth to this figure here, so we kind of have a 3D object here. We also have another dimension of depth. So volume is the space inside of this whole figure. It describes how many cubes of a certain size something will hold. So a cube, we should know, is an object that has 6 identical square faces. So here's a cube, each side being 1 foot long. So the width is 1 foot, the height is 1 foot, and the length is 1 foot. And so we would say that the volume of this cube is 1 cubic foot. And so we'd write that as 1 foot to the 3rd power. We use exponents to denote when something is squared or cubed. So this means 1 cubic foot. Now, a geometric solid is a geometric figure that occupies space. And the base of it is the region on which we stack the cube. So the base would be the bottom of the figure. And a right solid, or a right geometric solid, is a solid where the sides form a right angle with the base and has a uniform height. So to think about this visually, imagine this is the base of a figure. It's 2 centimeters by 3 centimeters. So that's the bottom of a rectangular solid. Okay, and if we had like sugar cubes or maybe Legos, let's say this is like the base of a Lego set, and then we took cubic Legos and put them in on that base. So you would need 6 cubes to fill that base. And so the volume of this geometric solid would be 6 cubic centimeters, because we're in centimeters here. And then if you added on another layer on top of that, so you made your solid 2 Legos high, you would have 12 cubic centimeters. And then if we added on another layer, you would have 6 more Legos on that solid. So then you would have 18 cubic centimeters. So there is a formula for finding the volume of a right solid, and that is taking the area of the base and multiplying it by the height. So we already know how to find area. We're just adding on another dimension, which is the height. If you just multiply that, you will get the volume of the right solid. So going back to this solid that we have that is has a base of 2 centimeters by 3 centimeters. To find the volume of this figure that is 3 centimeters high, we would find the area of the base first. So the area of the base is 2 times 3. And then multiply it by the height, which is 1, 2, 3. We put V for volume, volume equals, and 2 times 3 is 6, so our base is 6 centimeters squared, and then we multiply it by 3 for the height, so that would give us 18 cubic centimeters, which is exactly what we noted before. So here's another example. So a swimming pool is 9 feet wide and 20 feet long. Find its volume when the water is 6 feet deep. So here we can see a picture of the base of the pool. It's 9 feet wide and 20 feet long. And then here we have it in 3 dimensions when we add 6 feet of height. So we would find to find the volume, you would find the area of the base, which is 9 times 20. 9 times 20 is 180. And then we're going to multiply it by the height, which is 6. And if we multiply 180 by 6, we're going to get 6 times 8 is 48. 6 plus 4 is 10. So then our volume here would be 1,080, and the units that we have are feet cubed. So 1,080 cubic feet is the volume of that pool. Here are your practice problems. Go ahead and pause the video, work on them. If you need to look in your book to get better diagrams of what these shapes look like, you can do that. But basically, each of these shapes have right angles, so it should be easy to calculate. So go ahead and pause the video, work through those, and then we'll check your answers when you're done. Okay, first problem. Find the number of 1 centimeter cubes that can be placed in a rectangular box measuring 4 centimeters by 6 centimeters by 10 centimeters. Okay, so it really does not matter which numbers we use for base and height and length. So you can do this, multiply them anyway. So for here, let's just say our base is 10 by 6. Okay, so the volume of this box is going to be the area of our base, 10 times 6, which is 60. And then the height is 4. 60 times 4 is 240. And then our units are centimeters cubed. So the volume is 240 cubic centimeters. All right, here we have a sort of a different shape. On the left is a base of a right solid whose height is 12 meters. Dimensions, all the dimensions are in meters. Find the volume of the solid. So this is like if you were looking at the top of this figure from like a bird's eye view. So this is what the shape is. So we can figure out the area of the base first. So we might need to break this into 2 pieces of this figure. So this first rectangle is a 10 by 2, okay, which is 20 square meters. And then the second rectangle is 8 by 2, which is 16. So the total area of the base of the figure is 20 plus 16 is 36 meters squared. Okay, and then it said that the height of the figure is 12. So this height here is 12. So to find the volume, we multiply the base, which was 36, times the height, which is 12. And I already figured this out earlier. It is 432. And then our units are in meters, and it is cubed. So the volume of this figure is 432 cubic meters. And our last one, below is the base of a right solid whose height is 2 meters. Dimensions are in meters. Find the volume of the solid. So I don't have the three-dimensional picture of this one, but this is the base of it. So we need to break this figure into two pieces. We'll figure out the area of this rectangle and then the area of this triangle and add them together. So we have 5 times 6 for the rectangle. And then our triangle here is, this whole piece was 8 and this portion was 6. So that the remaining amount here is 2. And then the height is 5. So 2 times 5 is 10, but the area of a triangle is base times height divided by 2. So that area of that triangle would actually be 5. And this should be 5 actually, or plus, I mean. So 30 plus 5. So the area of this figure is 35 meters squared. Okay, and then to find the volume is going to be the base, 35, times the height, which was 2 meters. So our volume here is then 70 cubic meters. In conclusion, the volume of a right solid equals the area of the base times the height. That's all for now, so go ahead and do problem set 45 and then read ahead to lesson 46 in your textbook. Have a good day and see you next time. And don't forget to like this video and subscribe. It helps a lot. Thanks.